Okay, in this next video is section 2.2, part 1 video. And one of the things that we're going to talk about in this particular section one of the things, I want to talk to you about several things, but one of the things that I want to talk to you about is the idea of the perimeter of something. Now, simply put, it's just this. The perimeter of an object is the total distance, how far it is around that object. So if you took a tape measure and measured all the way around it, that's the perimeter of it. So if I said, what is the perimeter of a triangle? You'd add up how long the 3 sides are. Or if it's a rectangle, you'd add up the lengths of the 4 sides, etc. So, just to give you a couple of just real simple examples right here. In this first problem right here, and remember now, you can pause the video if you need to pause it and copy the video. I don't wait because you can pause it and it allows me to cover more material. So let's suppose you have this rectangle and I said find the perimeter. The perimeter would just simply be the total distance around this object, which is 3 plus 7 plus 9, which would be 19 feet. Now, let's suppose I have another triangle, X, Y, Z, and I don't know what X, Y, and Z are. What would the perimeter be? It would still be those 3 things added together. So it would be X plus Y plus Z. It's just you can't add X plus Y plus Z because that's 3 different, remember, talked about adding and subtracting like terms. These are not like terms. So that's not X, Y, Z. X plus Y plus Z is X plus Y plus Z. All right, so let's suppose we have another triangle. And I said, what is the perimeter? The perimeter would just simply be the sum of the 3 sides. So it would be the first side plus the second side plus the third side. Now, here's the difference. In this one, we can add some of this together because some of this is like terms. So we've got X plus the X plus 2 more X's, and that's 4X. And then you can add the numbers together. 3 plus 8 is 11, and 11 minus 4 would be plus 7. Now this is not equal to anything, so we're not solving an equation like we did in section 2.1. The perimeter is just that. So we're not solving for X here because it's not equal to anything. It just says, what's the perimeter? Well, if you add those 3 sides together, there's your answer. So the perimeter, 4X plus 7. That's your answer. Okay? Now, let's suppose I told you that this figure is a square. Now, you can't assume it's a square. You have to be told that it's a square. So let's, you're told that this is a square. Then what is the perimeter? Well, if you'll remember from geometry, what do we know about a square? All 4 sides are equal in length. So the perimeter would be 3 plus 3 plus 3 plus 3, which of course is 12 inches. And units are important in a problem. You know, I've told my classes before, they'll say, Mr. Brown, why do you take off when we leave off inches or minutes or hours? Because they matter in life. If you're going to come to my house and say, well, Mr. Brown, I'm going to come visit you. How long will it take me to get to your house? And I say, about 3. I mean, it matters. 3 minutes, 3 hours, 3 days. I need to know. So units on problems, particularly application problems, they make a difference. So we want to always make sure that we put our units if there's any in the problem. Okay, now let's do another problem very similar to what we did a while ago. Let's suppose I have a square and I ask you what the perimeter is. Well, if one of the sides is X, then all 4 of the sides is X. So X plus X plus X plus X, or 4X. Now you say, well, Mr. Andrew, since I know that this is going to be 4 of these, could I just write it 4 times X? Sure you can. But don't leave the answer that way. This is the simplified solution to that perimeter. Okay. Now, let's change it up just a little bit. Let's suppose I have a rectangle. Now, what do we remember from geometry about a rectangle? And you say, well, nothing. Well, then I'll remind you. If you have a rectangle, remember in geometry, if it's a rectangle, opposite sides are equal in length. So however long this is, that's how long this is. So I want to find the perimeter. Now, does the perimeter, do you add up just these two sides? No. A rectangle has four sides. So you have to add up all four sides. But we know what this side is if we know what this side is. This side also is 8x minus 4. And this side over here is 2x plus 3. So what I can do, if you write it out the long way, it would be 2x plus 3 plus 2x plus 3 plus 8x minus 4 plus 8x minus 4. Now, add your like terms together. 2x plus 2x is 4x. 4 plus 8 is 12x. And 12 plus 8 more is 20x. Now add the numbers together. 3 plus 3 is 6. 6 minus 4 leaves 2. And then if you have 2, but you lose 4 more after that, you are down 2. So 2 at 20x minus 2. Now, let me show you another way you could have set this up. In this diagram, how many 2x plus 3's do you really have? You have 2 of them. So you have this one 2 times. How many 8x minus 4's do you have? 2 of them. So what you could do is just do 2 of the 2x plus 3's, 2 of the 2x plus 3's, plus 2 of the 8x minus 4's. 2, this one times 2, and this one times 2, and then add those two together. It's just another way of setting it up. Now, let's finish this problem to see if we get the same answer that we did right up here. What does this 2 in front of that parentheses mean? We've discussed that over and over again. It's the distributive property. So if you distribute here and you distribute here, this is what we get. Now, I can add this together. 4x plus 16x is 20x. And then the 6, if you win 6 and then you lose 8, you are down 2. So you get the same answer. So regardless, that's the perimeter to the problem. Now again here, we're not solving these for x because it's not equal to anything. So you don't put this equal to 0 and move the 2. We're not doing that. This is the answer to that particular problem. All right, now let's look at our next diagram. Looks a little bit confusing at first. I will explain it. So, before you pause it and draw your diagram, let me mention this. Here's what we're doing in this problem. We're assuming that all of these are rectangles, and we're assuming that every one of these are equal in distance. So however long this is, this one is the same, this one is the same, this one is the same. I know it may not look it, but that's what we're assuming here. We're also assuming that these are all the same length as this one. Okay, you can pause it and draw your diagram. Okay, now let's get the perimeter. Well, one way you could do it is you have to, now there's no back sides to this. So we want to add, let's count how many sides we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's really 9 things we have to add together if we do it the long way. So something plus something plus something plus, we do that 9 times. Or a quicker way to do it would be, You have an x minus 3, but how many of them do you have? 1, 2, 3, 4, 5. So you have 5 of the x minus 3's. So x minus 3, 5 times, or 5 times x minus 3. Now, how many 2x minus 5's do I have? 1, 2, 3, 4. So it's 4 times this, 5 times that, and then you're adding them together. So let's show that. So it's 5 times the x minus 3 plus 4 times the 2x plus 5. That way you don't have to add 9 things together individually. If you distribute the 5 and distribute the 4, you get this. Now add your x's together and add your numbers together. Okay, let's look at this next diagram. And so you can pause the video now and copy this diagram down now. Okay, I'm assuming you've copied this video down, the diagram down now. And I want to know, what is the perimeter to this? Well, let's first see how many sides we have. And we're assuming that all of these are 90-degree angles. If that confuses you, don't worry about that. Okay, so let's look at, count up how many sides we have. Here we go. 1, 2, 3, 4, 5, 6. So we're adding 6 things together. So it's going to be blank plus blank plus blank plus blank 6 times. Now, none of these are repeated, so I can't use a shortcut to write this out. So I'm going to have 6 blanks with a plus sign in between every one of them. Well, the good thing is we know 4 of the 6 already. So I'm going to go ahead and write these down. So, there they are. Sorry about that. I cut that off on you. So it's x minus 11 plus x minus 2 plus 2. But there's 2 other blanks that we have to fill in. So pause your video and copy this now. Okay, now what we need to do is fill in these last 2 spots. All right, so let's do that. All right, let's fill in this spot right here. Let's do this side right here first. Okay, so we're going to put this, we're going to figure out what this is. All right, how far is it from here to here? It's 11. The whole way. Now, if you start here and come down, it's 2. So from here to here is 2. So that means from here to about right there is 2. We need to know how far it is the rest of the way. Well, if from here to here is 2 and the whole distance is 11, then how do you find out what's left? You take the total side, which is 11, minus that short little piece, 2, and that leaves 9. So this distance right here that's 9, that's 2, and so that gives you the whole 11. So this is 9. So you can go ahead and put 9 in right there in that next blank. Now, you got to fill in the last blank. Now, where's the last side? The last side is right here. All right, I don't know how long that is, but I know this. If you look all the way across the bottom, it's 11 minus 2. So, flip this over. So, all the way across the bottom here is x minus 2. All the way across. I'll tell you why I put that in parentheses in just a minute. All right. I need to know how far it is from here to here. I don't know. But I know from here all the way across is x minus 2. From here just to right there is x minus 11. That's part of the way. we need to know what the rest of the way is. So here's what you do. You take the total distance and you subtract off this part, and that will give you what's left. Now, it's very important that you put this in parentheses since it's two terms. So it's the entire full side minus that piece. And that's kind of what we did a while ago. It was just with numbers. We did the total side minus the piece to get what was left. All right. Remember, we have to get rid of grouping symbols. Distribute the negative. This is going to become negative x plus 11. The x's add out to 0, and negative 2 plus 11. So this side right here just so happens to be 9 as well. Now, they don't have to be the same, but they were in this case. So this is 9, and this is 9. So now, I can go back to my original problem, and in the two blanks, see this. In the two blanks, I want to put 9s. Okay, so you're going to have a 9 right here and a 9 in this next blank. Now, add up all the like terms. Well, you got an x plus an x, which is 2x. Now add the numbers. Negative 11 plus 11 adds out to 0. Negative 2 plus 2 adds out to 0. But then you got the 9 plus 9 on the end, which is plus 18. So the answer to this problem is 2x plus 18. Okay. Now what I want to do is I want to show you how we can actually use algebra to actually solve a problem. Now we're going to look at a couple of very specialized cases of problems in order to solve these. What we're about to do is we're about to look at a problem where the instruction will be find out what the two numbers are, or find out what the three numbers are. So these are what I call number application problems, where they give us some information and we're looking for two numbers or three numbers. This will, right at the 18-minute mark, so I will stop the video at this point. We will have probably another 15-20-minute video in section 2.2, and that will complete section 2.2. So this is 2.2 part 1. The next video will be section 2.2 part 2.